The life cycle of stars, from nebula to supernova and beyond. Stars are the brilliant engines of the universe, responsible for creating light, heat, and even the elements that make up life. But like all things, stars are born, live, and eventually die. Their life cycle is a remarkable journey shaped by gravity, pressure, and time. 1. Birth in a nebula. Stars begin life in nebulae, vast clouds of gas and dust floating in space. These clouds are cold and dense. Sometimes a nearby explosion or collision triggers a disturbance, causing gravity to pull clumps of matter together. As the material collapses, it forms a protostar. Over time, the protostar grows hotter and denser. When its core reaches about 10 million degrees Celsius, nuclear fusion begins. Hydrogen atoms fuse to form helium, releasing energy. This marks the star's birth, and it enters the main sequence stage. 2. The main sequence. During this stage, the star is stable. It fuses hydrogen into helium in its core, producing light and heat. Our sun is currently in this phase, which can last billions of years. The balance between gravity pulling in and fusion pushing out keeps the star stable. The star's mass determines how long it stays in this phase. Massive stars burn fuel quickly and have shorter lives. Smaller stars like red dwarfs can last trillions of years. 3. Red giant or supergiant phase. When the hydrogen in the core runs out, fusion slows. Gravity causes the core to shrink, heating the surrounding layers. This ignites fusion in outer shells, causing the star's outer layers to expand. The star becomes a red giant for medium stars or red supergiant for massive ones. In red giants, helium fuses into heavier elements like carbon. The core becomes unstable as heavier elements build up. 4. The end of the line, star death. What happens next depends on the star's mass. Low to medium mass stars, like our sun, the outer layers drift away, forming a glowing shell called a planetary nebula. The remaining core becomes a white dwarf, a hot, dense object about the size of Earth. Over billions of years, it cools into a black dwarf, though none exist yet. They take longer than the age of the universe to form. Massive stars. These stars continue fusing heavier elements up to iron. Once iron builds up, fusion stops producing energy. The core collapses, triggering a supernova, a massive explosion that outshines entire galaxies. 5. After the supernova, neutron star or black hole, a supernova leaves behind a compact core. If the core's mass is about 1.43 times the Sun, it becomes a neutron star, an object so dense that protons and electrons combine into neutrons. If the core is more massive, it collapses into a black hole, a region where gravity is so strong that not even light can escape. Why stars matter? Stars are more than distant lights. They are factories of elements. Fusion in stars creates carbon, oxygen, iron, and more. Supernovae scatter these elements into space, enriching gas clouds and seeding the next generation of stars, planets, and life. In fact, every atom in your body heavier than hydrogen was forged in a star. We are quite literally made of stardust.